How can you prevent welding burn-through on thin materials? Imagine you're working with a delicate sheet of metal just a few millimeters thick. One wrong move, and the entire piece could be compromised. That's what makes preventing burn-through so important. Burn-through happens when excessive heat causes the weld pool to melt right through the metal, creating holes and weakening the joint. To stop this from happening, you need to control the heat you put into the material and use the right techniques. Start by lowering the welding current. For thin metals, a good rule of thumb is about 1 ampere for every thousandth of an inch of thickness. For example, if you're welding a metal that is 0.01 inches thick, set your machine to around 10 amperes. This helps keep the heat in check. Next, choose the right welding process. Gas metal arc welding in short-circuit transfer mode works well with small diameter wire, like 0.0 to 3 inch, and a shielding gas mix of 75% argon and 25% carbon dioxide. This combination helps control heat and prevents burn-through. Gas tungsten arc welding, also called tungsten inert gas welding, offers precise heat control and produces clean welds, making it ideal for very thin materials but needs a skilled operator. Moving the welding torch faster is another key step. Increasing your travel speed reduces the time heat is applied to any one spot, limiting how deep the weld penetrates. Keep the arc length consistent and moderate, about the same as the diameter of your electrode. Holding the electrode at a shallow angle, rather than vertical, helps direct heat into the weld rather than into the base metal. Use short weld passes instead of long continuous beads. Making small stitch welds or tack welds and filling gaps later prevents excessive heat buildup. Always clean the metal thoroughly before welding. Remove rust, dirt, oils, and coatings so the arc stays stable and heat distributes evenly. Be careful not to overgrind edges. Leave some material at the edges to withstand heat. Choosing the right shielding gas matters too. Using argon-rich blends instead of pure carbon dioxide can reduce the energy in the weld pool, lowering the risk of burn-through. When welding, push the electrode rather than pull it. Pushing directs heat into the weld bead, not into the base material, helping prevent holes. Before starting, double-check all machine settings. Make sure the amperage, voltage, wire feed speed, and gas flow match the requirements for thin materials. In manufacturing, these techniques are especially useful when welding thin sheet metals, tubing, or small precision parts. Following these steps ensures your welds are strong and clean without risking damage to the material. By carefully controlling heat input, selecting the right process, and using proper technique, you can keep thin materials safe from burn-through and produce high-quality welds every time.